I'm given here a rational function, g of x, and told that it's equal to negative 7x minus 8, blah, 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 blah. And we're asked for a couple things. First of all, I want the inverse of g. I want the inverse function. And I want domain and range of both. So the way we're going to do this is very similar to what we did for linear and cubic functions before. It's a method you can use for any function, which is first, write it in terms of y equals. Okay, say y equals negative 7x minus 8 over negative 10x plus 11. And this would go for a cubic function too. You'd follow the same technique. It's going to get a little nastier with this one because it's irrational. Next thing is you switch x and y. So we literally switch them. We say x equals negative 7y minus 8, all divided by negative 10y plus 11. Okay, so step 2 is done. Step 3 is get y by itself, which in this one is going to take a little bit of work. We have to get y on one side of the equation with nothing else around it. And you can see what's in our way first is that there's a nasty fraction on the right side. So how do you get rid of fractions? Remember, you multiply each side of the equation by the denominator. So I'm going to need a little more room down here. Let me just move this. You know what? Let me just move the whole thing right there. Okay, so there's x equals this thing, and I'm going to multiply both sides by the denominator, negative 10y plus 11. And over here, same thing, negative 10y plus 11. Okay, so break that out, see what we get. On the right side, these cross out, and I get negative 7y minus 8. Great. On the left side, I get negative 10xy plus 11x. Well, goal number 1 is done. There's no more ugly fractions. I don't have y by itself on one side, so let's do that next. I'm going to, what do I do? I'll just add 7y to each side. Plus 7y plus 7y. And I'll do minus 11x on each side. So now, once all the dust settles from this, look at what we have. 7y minus 10xy on the left equals, looks like negative 11x minus 8 on the right side. The advantage of what I just did is now all the y's are on one side of the equation. I'm not done yet. They're not by themselves, but this is good progress. So next, what you're going to do is factor out y, and you get 7 minus 10x after you take out the y GCF. The right side hasn't changed. Okay, that's still this. And now I'm only one step away from being done. I just divide each side by whatever y is multiplied against. So I'm going to divide each side by 7 minus 10x. Okay, 7 minus 10x. And here, this is basically our answer, because on the left side, those cancel out. So what I get is just y. Y equals this thing. And remember what y is. This is the inverse of g. Okay, remember we made that substitution at the beginning? Now you can take this thing and write it in our original answer box. This is going to be negative 11x minus 8 over 7 minus 10x. I think irrational is one of the harder problems to find the inverse of, just because we have a little bit of algebra to do here. But if you follow the steps, it's the same 4 steps as before. First step, write it in terms of y equals. Second step, switch x and y. Third step is just solve for y. Okay? So now we talk about domain and range. And if you look at g of x and think, what's the domain of that thing? Well, where's g of x? It's this guy right here. The domain restriction is the following. You can't have the denominator equal to 0. So that means negative 10x plus 11 cannot be 0. Well, solve this equation. Let's see what we get. Negative 10x cannot be negative 11, which means x cannot be 11 over 10. I just eliminated the negatives when I divided. So that gives us the following domain. It's going to get a little scrunched here, so I'm just going to write it above the line. The domain equals negative infinity all the way to 11 tenths. Okay, can't be 11 tenths. It's going to hop over that domain restriction and pick up on the other side, going from 11 tenths to infinity. Okay, that is the domain of g of x. And we're going to follow the same line of logic for the domain of the inverse, which is down here. The domain of that one, if I think I have room for it, 7 minus 10x cannot be 0, which means 10x cannot be 7, which means x cannot be 7/10. Okay, so we write that in the same way we did before. I'm going to say negative infinity all the way to 7/10 union 7/10 all the way to infinity. That's the domain of the inverse of g. Now, you may be a little worried about range. Don't worry. You can plot these things if you want to, right? You can graph a rational function. We've done that before. But I say it's quicker to just recognize that the domain of g is the range of g inverse, and also that the domain of the inverse is the range of g. Okay, so you can just write those down here.